Arnason, colleagues and guests. Seeing the subject that I was assigned to for this conference, visual impacts and energy transmission, it gave me some pause in the beginning. Maybe perhaps because in 20 minutes there are many issues to talk about in connection with this. So it's not because of loss of words, there are many topics that you could go into for the subject. I am, let's see, in this lecture going to give you a small overview of some of these issues, and I'm going to talk about, in the end, namely the title, the effects of energy transmission on landscape and visual amenities. But I'll start wide, and then I'll focus my attention on these challenges we're facing here in Iceland, challenges which many of you may know from your countries of origin as well. First, I'd just like to tell you a bit about EFLA, the company I work with. We're a general engineering firm, about 250 people in staff, with services in all main disciplines of engineering and related fields. We're based in Iceland, with our headquarters located in Reykjavik. We have offices here in the south, north, and east of the country. But we also have offices or affiliated companies in Norway, Poland, France, Russia, Turkey, and Dubai. You can also see from this map that our experiences range far and wide. Of these projects that we have here located, I tried to find out which of these are connected to energy transmission and the utilization of geothermal energy, mainly design. I think this is about it. So these are the main areas where we have had this experience. We worked in geothermal energy as far as New Mexico and in Indonesia, Africa, Turkey, Croatia, in addition to Iceland. But our main experience is in transmission. Our role in each project is different, of course, but throughout this experience we've seen that the emphasis when it comes to environmental issues is different, and design requirements are different between countries. So overall, if we look at the environmental requirements and standards, we've got the relevant national environmental assessment procedures and licensing processes that we look to, but we also have, in many cases, environmental standards and preparation procedures that are issued by development funds such as the World Bank or the IFC, the Equator Principles, and so on to look at. But we also see, like Stefan did mention, that the stakeholder involvement is different. And I put here that the values are different in emphasis as well. This is something that links to what I'm going to talk about later. But in general, these are the issues that we look at when we do an environmental impact assessment for power lines in Iceland. And as you can see from this and compare it with what Stefan had earlier on in this lecture, it's similar. And I think if you compare it with your experience from other countries, it's probably going to be similar as well. But I do agree that the social aspect and the social emphasis is a bit slightly less here. When we then look at the design standards and requirements, there are other issues that we have to consider, and these control what options and alternatives we have. If you focus on overhead transmission lines, for example, we've got the weather conditions and weather loads, which are a big part here in Iceland, for example, as you can see. We've got rights-of-way issues, adjacent land use, we've got electric and magnetic fields, and we've got these issues with dense urban areas, or visual aspects, direct impacts of some sort, or special environmental requirements. So, in addition to this, you know that for the options that we have, the discussion on the feasibility of other alternatives such as underground cables is big here in Iceland at the moment, and there's probably many other places in the world that have the same issue. I'm not going to turn my attention on this detail into any depth, but you may know that on high voltage this is a big issue because of multiple costs, because of technical implications, because of duration, etc. But it's also an issue when it comes to assessing landscape and visual effects. Now, this also links with the third issue, which is that there can be a difference in the characteristics of the geothermal sites that we're looking at. And therefore, there's a difference in the emphasis in environmental issues. I didn't do anything, so hopefully this is not going to happen again. As these three photos show, there's a difference between these sites. One of them is from New Mexico and shows the clayish desert sites there. One is from the lava fields of Reykjanes Peninsula, and the third one is from a densely populated tropical area of Ólafur in Indonesia. So the challenges in terms of power transmission and connections to the grid are going to be different for these sites, for sure. Now, let's then turn our attention to Iceland. Stefan did save me some time in his lecture. I'm not going to have to spend much time on explaining this. This is just to show you the geothermal active sites. I can instead use the time to tell you that, of course, this is the newest system and it gets aging in both directions, but we've got an active area over here as well. And this is the area where Jules Verne said that Professor von Hardwick went down to a glacier at one time with his nephew, Axel, and an Icelandic guide called Hans, in a tale about the Snæfellsnesjökull area. I think it's actually the first and only time it has been tried. Okay. In Iceland, the main transmission system is run by Landsnet, which is a publicly owned company, and it's responsible for the maintenance and operation of the national grid. So it's responsible for the connection of power producers, large consumers, and to distributors, who then distribute to smaller companies and homes. To give you a short summary of the system, the main circle surrounding the country, shown by a red line here, is 132 kV, which was erected in the 80s, you could say. We then have a stronger 220 system in the south of Iceland, connecting the main populated areas, the big producers here, with many of the biggest hydroelectric plants here in the south. We also have a 220 kV line going from the Fljótsdalur power station down to the aluminium smelter at Reyðarfjörður. In a nutshell, the grid's total transmission length is around 3,200 kilometers. It operates at a voltage between 30 or 66 kilovolts and 220, has 72 substations and around 77 supply points. This maps then show you the transmission system, again now simplified into black lines. What we have here also are the opportunities Iceland has for the utilization of geothermal energy according to the master plan for hydro and geothermal energy resources in Iceland. So the red dots show you current geothermal sites, the green dots show the sites proposed for utilization in the master plan, pending environmental assessment and other such processes. And the blue dots show the sites that can potentially be used or utilized in the future, but have to be researched further before a decision is taken. Although on a small scale, this does give an indication of some of the challenges that Landsnet is facing, that is to connect these areas to the grid. Of course, there are other challenges that Landsnet is facing with the strengthening of the overall grid to account for increased development, since an aging grid is already a challenge when it comes to operation. Overall, Landsnet is faced with major investments in strengthening the system during the next few years, or the next years. In this preparation, the overhead transmission lines in urban areas with a voltage of 66 kV or above are subject to EIA. And these processes, in addition to planning issues and licensing, takes time. And Landsnet has shown the initiative to start these preparation processes early, and is already underway with this for a number of important projects in strengthening the main system. Now, at the local scale, when it comes to environmental issues, Iceland has the responsibility to assess the impacts of the connections to the grid. This is usually done in parallel with the EIA that the energy company carries out for the geothermal utilization, but not necessarily. The main characteristics of the sites, and I'm now focusing on landscape and simplifying the matter a bit, is that they're geologically active, the landscapes are open and young, and usually they are in unpopulated areas. The ones that we are looking at are in unpopulated areas. And in some cases, these can be defined as pristine. They are usually popular for recreation and tourism, and they have stayed popular, many of those, even after having been developed for the utilization of geothermal energy. But this brings us to the options we have for connections. The first option is always to use overhead transmission lines. But in many cases, these areas are unsuitable for underground cables. They've been considered underground cables, that is, in some cases, for a short distance to connect between each turbine and the substation. But even this is not feasible in all cases. Direct impacts of high voltage cables are more extensive, in some cases 3 to 4 times more extensive than for overhead transmission lines. Furthermore, they're more sensitive to earthquakes and heat, which means that the changing surface temperatures due to geothermal utilization is a threat, as well as the poor qualities of the soil for laying cables. So, of course, I'm generalizing here, but these have proven to be an issue in some cases in our experience. So this leads us then to landscape. According to the countryside agency, this is what the term landscape looks like in a way. It's divided into the physical environment, natural and cultural, but it's also the perception and the aesthetics that play a big part, which means it's a highly anthropocentric issue. It's an amenity in a way that we sense and value differently. So when we're trying to assess these impacts, it tends to be problematic. These values can also shift over time. I've got examples that I think some of you have seen, but I like them, so I'm just going to show you. These examples are of different perceptions. They're quite old, but they describe the description, well, it's a description of 2 of our national parks, Þingvellir, which is now a UNESCO site and one of Iceland's most prized jewels, and from Mývatn, which is a Ramsar site, and it's known for its rich wildlife and landscape. Now, first of all, there's a description made by a committee which was assembled by Iceland's most educated in the year around the beginning of the 19th century. The committee's task was to assess the future of Alþingi and Þingvellir, and the description given by the committee goes like this, and in this period it's in Danish, but I'll try to translate it. The place by Öxará, which is where Alþingi is located, is not only one of the ugliest, but also the one most badly suited for food production. If you then look at the other matter, which is Mývatn, it's taken from traveling notes made by 2 Icelandic explorers, but the work is historically very important for Iceland and the nation's knowledge on nature and society at the time. In the summer of 1752, when they came to Mývatn, and the description of the area was as follows. When we came down from the heath, the Mývatnssveit area appeared black and ugly looking. Of course, the vegetation may have been a bit different at the time, but still, you get the point. So it does tell us that value can shift. Good judgments we made today may be the mistakes we make tomorrow. So at least we have to be transparent in our judgments and present it well. Here in Iceland, this is a big issue. There is research that has shown that it's one of what we consider one of the main national characteristics of Iceland's landscape. And as a consultant, I think I can confirm that it's a big issue when it comes to preparing medium and large-scale projects here in Iceland. If you haven't already been into 2 social events, and I think you've heard this joke before, I could describe it in one joke: Icelandic landscape. Should I attempt to do that? What do you do if you get lost in an Icelandic forest? And the answer is you stand up. It's usually open landscapes, high visibility. It's large wilderness areas in the highland regions. So the EA emphasis is on visual impacts, on recreation, inhabitants, etc. And then the direct impacts on landscapes or sensitive areas, such as unspoiled lava fields. So for transmission lines, for example, the main debate is, shall we use overhead transmission lines or underground cables? And this affects our approaches. But for the assessment of overhead transmission lines, the focus turns more to the visual impacts. Since the direct impacts are in most cases less. So I'm going to spend a few minutes on the visibility analysis of photomontages. What we usually do is we use these methods. We use aerial photos, 3D terrain models, or 3D fly-through models, or PDFs. We use photomontages and visibility maps. And I'm just going to describe the last 2 a bit. At EFLA Engineers, we have developed a software to analyze visibility of overhead transmission lines. It's different from the available GIS-based solutions in 2 aspects. It takes distance from a specific viewpoint into consideration, and it also takes partial visibility of the project due to terrain into account. So the outcome is a scale of visibility, usually shown as square meters of project visible. This is different from other visibility models in the sense that they usually show the number of pylons visible and without taking distance or partial visibility into account. So for this example, we have something like this. Okay? But if you take this case, this, for example, shows you the visibility of a current system nearby Reykjavik. It's calculated for around 500,000 points for a person around my height, 179.5 centimeters. So it shows you from each of these points how much do you see of pylons. It can be down to none, and then it's a gradient of how many pylons do you see, how far you're located, etc. You then do the same calculation for the proposed system, and to help you with the changes, you can as well do a difference analysis. So this shows you the increase or decrease of visibility for a certain site. This can help you in trying to locate the main impacts. What it also does is that if you then connect this with certain viewpoints, it does give you a scale of some sort of how we implement this scale and what does it show. So in our case, this has been very helpful. We then use photomontages to support what we are looking at as well. And in some cases, it can be the other way around. And by providing these 2 data, in our opinion, we can at least present how the project looks like, and give people kind of a scale to put that into their own perspective. Now, for summary and results. The connection of geothermal plants to the energy transmission grid has to undergo environmental assessment, and this can be a challenge, especially in regards to visual effects. We say in the assessment emphasize transparency, keep it simple, and use visualization and presentation. Use data from other parts of EIA if available, such as tourism studies, etc. But all the tools that we have, we can spend loads of money and time trying to do the analysis. You just have to decide on a case-by-case basis what's necessary. There's no need to go all the way all the time. So thank you very much.